What's up, everybody? I'm Steve, and this is USACO 2024 December contest at the bronze level. Problem number 3, it's Mooin time. Farmer John is trying to describe his favorite USACO contest to Elsie, but she is having trouble understanding why he likes it so much. He says, "My favorite part of the contest was when Bessie said, 'It's Mooin time,' and mooed all over the contest." That's pretty funny, actually, I gotta be honest. Elsie still doesn't understand, so Farmer John downloads the contest as a text file and tries to explain what he means. The contest is defined as a string of lowercase letters, n, where n is between 3 and 20,000, up to 20,000 letters. There's no major red flags on that. If it's 10 to the 5th, that's our big warning sign, but this is 2 times 10 to the 4th. We might be able to get away with some kind of a simulation on this. I don't know exactly what that simulation is going to look like yet. We're going to have to stay tuned. But 20,000 is kind of right on that edge where you could probably get away with a simulation, assuming it's a really efficient simulation. A moo is generally defined as a substring CI, CJ, CJ. Some character CI followed directly by 2 occurrences of the character CJ, where CI is not equal to CJ. MOO, But also BAA, bah, that's a moo, apparently. XQQ is a moo. But FFF, which is how I felt after reading that meme, does not qualify as a moo because CI and CJ have to be different. According to Farmer John, Bessie moos a lot. So if some moo appears at least F times in the contest, where F is between 1 and N, that might be from Bessie. However, Farmer John's download might have been corrupted. Farmer Naj at it again, I'm sure. And the text file might have up to 1 character that differs from the original file. Through the course of the entire string, we're allowed to change 1 single character to 1 other character. Print all possible moves that Bessie could have made, taking the potential error into account, sorted in alphabetical order. The alphabetical order part shouldn't be too difficult, but it's going to depend on how we're storing our matches. The first line contains N and F, N, and F, representing the length of the string and the frequency threshold for a moo by Bessie. The frequency threshold is F, which means unless it occurs at least 2 times, we're not considering it. So for example, there's a OZZ in here, OZZ. That one's not going to count because that one only occurred once, and there's no way to make it occur more than once. The second line contains a string of lowercase letters of length n representing the contest. We want to figure out what do we have at least 2 of. We've got Z, Z, MOO, Z, Z, MOO again. So we've got moo here, moo, and moo that occurred twice. But remember, we're allowed to change 1 character. So let's see if there's anything else we can get enough times to create a moo out of, because it doesn't have to be MOO. For example, we've got OZZ. Could we make another OZZ? Well, I guess potentially since we could change 1 letter, we could change this to a Z, and that would be OZZ from here to here. But we're not allowed to have overlap. This is another really key part of this problem. They clearly didn't include that in the sample output, and it's because of this overlap right here. So they have to be distinct from each other. Also, I've got a ZZ here, but there's no character before that. I can't add any characters to make OZZ. So that can't count as a mutation. It has to mutate an existing character. In this case, no change affects the answer. The only moo Bessie made was moo. Next one, M-O, we're going to do this one all the way out, M-O-O, B-A-A, A-A-A, Q-Q-Q, C-Q-Q. We'll go ahead and look at the sample output. It says there's 3 of them. Remember, we need to have at least 2 occurrences in this example. There's 3 that we could do. A-Q-Q is one of them. So here's one A-Q-Q. Where's the other A-Q-Q? Remember, we can change up to 1 character. So we could use this C-Q-Q back here and change the C to an A. And that's how we could get an A-Q-Q. Also says we can use BA, B-A-A. There's one of them obviously right here. The other one, same thing. We're going to have to take this AAA and change the first character to a B to mutate it, and that'll give us our second BA. And then they said CQQ is one as well. Well, we already have a CQQ. We can get 1 more from mutation. Maybe right here, this AQQ, we could change to CQQ. In order to have 2 hits, we have to have at least 1 that occurs naturally. And once we figure out where that 1 is that occurs naturally, we're allowed to have up to 1 more that occurs by mutation, which may or may not exist. If, on the other hand, they wanted us to find 5, there would have to be at least 4 occurring naturally, and then 1 that we could make using mutation, or 5 occurring naturally, or 6 occurring naturally. But either way, we have to find at least 1 less than whatever our F value is naturally occurring in the set. Let's see if we can work backwards on this one. I need to have at least 2 in order to qualify, which means the only thing that can work is things that already are naturally following that pattern with at least 1 occurrence. I've got moo here naturally occurring. I've got ba here naturally occurring. I've got AQQ here naturally occurring. And then I've got CQQ here naturally occurring. Those are potential moos. Now we got to figure out, can we get at least 1 more by mutation? So in the case of CQQ, I can mutate AQQ. In the case of AQQ, I can modify CQQ. For BAA, I have this AAA here that I can mutate, and that qualifies. But mu didn't work out. And the reason mu didn't work out is because I can't have an overlap, which means I can't turn MOM into mu. And there's nowhere else that I have a double O or an M space O or an MO and then something else that I could mutate. That's going to be pretty important. First, seeing whatever your F is, how many XYY style patterns, how many CI, CJ, CJs are there that have at least F-1 occurrence. And once we figure out what those are and build a list of them, we then need to see, is there another one we can create that doesn't have some sort of an overlap? Unless there's already F of them. If this was already a B, we don't have to mutate. Anything that has F occurrences or more is already qualified, and anything that has F-1 occurrences, we need to try to find one more that doesn't overlap with an existing CI, CJ, CJ, or XYY style pattern. One more sample case to look at. I've got OOO, and I need to have at least one occurrence. Well, that means that anything that has 0 occurrences would qualify. So potentially, we would have ABB, ACC, ADD. So the number of choices for first letter is 26 letters. The number of choices for second letter is only going to be 25 letters. If we multiply those, we're going to have something around 670. I'm going to go ahead and actually calculate that. I'm too dumb to do math in my head. 26 times 25. 650. 650 possible combinations. Times 20,000. With like about 3 to 6 comparisons each. Let's just call that 10. Say like we got to do about 10 steps each. 10. Multiply all that together. We're at like 200,000. Let's just add 3 more zeros onto the end of it. 0, 0. 200 million. It's cutting it close, but I think we can simulate this. So we've got 25, and the reason why it's 25 and not 26 is because OOO is not going to be in this list if you look through this. We only can have AOO, BOO, COO, and so forth. You can check that. MNP, the O is missing because the letters have to be different from each other. So I can mutate this first letter into any one of the 25 other letters of an alphabet. I just can't have them all be the same. All right, so on to the visualization. So if I have MOMOO, I have one mu already, but I can't get 2 mu's out of this because even though I can technically mutate this M into an O and have a mu here, I would lose the mu over here. And these can't exist at the same time. Mo, we'll do mu, ba, a. Let's do ba-bow. So in a situation like this, we have a mu here, and then this O, we could mutate to an O. That technically does disable this ba, but they don't have to exist all at the same time. And even though I have like BAA and then BAW, and I want to be able to make this into ba so that I can get 2 bas, if I mutate this B here and I have mu and I lose a ba, that's okay. At one time, I can have 2 mu's, and at one time, I can have 2 bas. And then that allows both mu and ba to have 2 occurrences, including a mutation. When we talk about a mutation breaking something, is a situation where I have something like this. I have MOMOO. I already have a mu here, and if I were to change this, that creates a mu and destroys a mu. There are 3 potential letters that can be altered. If I have a mu, then that already counts. If I were to take an R here and have MOR, then that's fixed by mutating the 3rd letter. If I have MRO, that's fixed by mutating the 2nd letter. If I have ROO, that would be fixed by mutating the 1st letter, if my goal is to create mu's. So say like I already have a mu right here, here, and here. This is already a mu, and this one has a missing letter. The letter's missing either here, or here, or here. In each of those situations, we have 1 or 2 things we have to watch out for. Let's say like the letter is missing on the 3rd character, and it's already an M. We have to be careful, because if that is followed by an OO, if I have an MO and then an MOO, changing the 3rd letter here to make this into a mu, then I gain the mu here and I lose the mu here. This is the first thing to watch out for. Second situation is when the 2nd letter is wrong. The thing we have to watch out for here is if this is an M followed by 2 O's. Let's say in this case we're going for 3. So I've got MOO here, I've got MOO here, and I see that I have 2 occurrences of mu, and now I'm looking for my mutation. Look for my mutation, I say, okay, well here's a case where I could almost mutate because I've got 2 out of 3, and I want to mutate this middle letter. What I need to watch for is this middle letter the start of a mu? I can't mutate this either. First letter wrong is a slightly more complicated. So I found my first mu here, mu. I found another mu here, mu. And now I'm going through looking for a mutation. I hit this where I've got 3 letters in a row that don't form a mu, but I've got 2 out of 3. And I want to potentially mutate this first one to be an M to make a mu. If this is already an O and it's preceded by an M, then I can't mutate this one to make an M because I'm gaining a mu and losing a mu. There's a second situation though. I'm gonna need one more O. I'm iterating through, considering sets of 3, and I get to this set of 3. This set of 3 cannot be turned into a mu. Also, this set of 3 can't be changed to a mu because once again, that would break the third letter. So if starting 2 letters before, the letter you want to mutate is the third letter of a mu. In either case, you can't mutate it. You need one more O here, and then finally, when you get out here, this is safe to do because it's not preceded by an M, and it's not preceded by an MO. Let's try just a couple general use cases. We'll just randomize some letters. I'll do mu, I did a ba. Oops. Sorry, FJ. And then mu again. Morba-mu. So for Morba-mu, I have a mu here that I found. I have a ba here that I found. If I'm trying to get 2 matches, then what I would do iterating is I would see here is an MOR. This is the third letter that is wrong. I want to make sure that if I change this, this doesn't break an existing mu. And this is not an M, and it doesn't start a mu, which means this is safe to mutate to an O. And now I've got my second mu and mu. Let's do BBA, preceded by some R's. MOW. We're gonna try and do 2 matches. So first thing we do is we look through, trying to find a letter that's different than the one after it, and then those 2 letters are the same. So here, no match, here, no match, no match. Oop, here's this letter is different than this letter, and this 2 are the same, so that's 1 success for mu. We check here, we check here. Oop, and here's an RBB. That's technically a mu. They don't have to be vowels. It's just 1 letter different from the next, 2 letters the same. And then I get a BAA. Let's go ahead and mark those down. So I got a mu, MO, I got an RB, and I got BA. So these are the ones that I want to consider. I want to have 2 matches in order to qualify. So I've got 1 here for MO, I've got 1 here for RB, and I've got 1 here for BA. So first we're going to go through and we're going to try and make a second BA. So what we're looking for is a situation where I have 2 out of 3 for BAA, where making that into a BA is not going to break it. Nope, 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 nope. Here's 2 out of 3 because I have a B here and an A here and have 1 that's not correct. So we want to check, can I change this to make this into a BA? If this is the one I want to mutate, and that's currently a B, I need to make sure that B doesn't begin a BA that already exists. And I check and see that it does, BAA. What that means is I can't mutate this one. We also have to check to make sure we're not going to go out of bounds. Because if we're here and then we try to check if this is a BA and we go out of bounds, then our code's going to crash. So we have to have a bounds check. We can't make a second BA, which means BA's off the table. Let's try for RBB. So here, 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 here. Nope, none of that's even close to being able to make an RBB. We can take RB off the table. Last check, we're looking for mu. Oop, here's a 2 out of 3, MO, not an O, but this begins a mu. This last one begins a mu, which means we can't mutate it. Ooh, that's close. I've only got 1 out of 3. Here's a mu already. It doesn't do us any good. ORBAA, and mu's off the table. So in this case, we couldn't make 2 of anything. I'm gonna set one up where it's a first letter mutation. Let's swap some A's in here. One more A. Say like we're looking for 3 matches. We're gonna go see if there are any potential candidates. Here's WMO, MOB, OBA, here's BAA, here's AAA, that's no good, AAA, AAA, AAA. Here's another BAA that puts us at 2, and then AAO. We have 2 BAAs. If we're gonna do 3 matches, we have to have at least 1 less than our target. If our target is 3, we've got 2 of them, then we gotta try to find if we can do 1 by mutation. WMO is not good, MOB is not good, OBA is not good, BAA already is. AAA potentially would. That's a first letter mutation to make this into a BA. So we have to check 2 things. Is there a BA here? And the other is there a BA here? These 3 are not gonna work. Here's 3 again. That's AAA. If we were to put a B here, that is the third letter of this BA here. So we can't mutate that one either. Get here, AAB. Can't turn that into BA. Can't turn that into BA. That's already BA. And then AAO is not good. So I can't get 3 BAs out of this one either. We're gonna do MOO, Let's say like our target is to come up with 3 of something. Despite the fact we have an RAA, we only have 1 of them, which means we can't get that up to 3 with 1 mutation, so we won't consider RAA. AMM, we only have 1 of them. What we have 2 of so far is mu, so let's go ahead and put mu as a candidate, MO, and then also ORR twice. So we're gonna put OR as a candidate, OR. Now we're gonna look through and see if we can create a third of any of those. So we'll start with mu, that's already mu. That one I can't turn into a mu. that one. It's got to be 2 out of 3 to mutate. Can't mutate, can't mutate, can't mutate, can't mutate. Ooh, here's an MMO. That's missing 1 letter. But the second letter is the start of a moo, which means I can't turn that into a moo. That's already a moo, and nothing and nothing. Let's try it with a target of 2. Here I've got MOO. That's a potential candidate because I only need F minus 1. OOR. Here's OR again. That goes on the table. RRA. RAA. That'll go on. RA. Here's AMM. MMO. Here's moo again. OOR and OR. If I'm only looking for 2 matches, then I've got moo in here twice and I've got ORR in here twice. I don't need to check for mutations for these. These already have 2 matches. So I'm going to kind of move them over into my solved category. The only ones we need to try to mutate for are going to be RA and AM. Let's see if we can make another RAA. No, no, nope. Oop, here's RRA. But again, the middle letter starts in RAA, so that's no good. That's already RAA. That's no good, no good, no good, no good. Here's an RR, but we can't add new letters in the end, and that's not an A anyway, so that's not quite there either. So RA is not going to be possible. Let's try AM. So MO. OR, or blah, 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 blah. Here's AAM. That's a middle letter mutation. But again, that middle letter starts in AMM, so I can't mutate it. That's already AMM. No, 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 and no. So AM is off the table. The 2 that had 2 successes, I wasn't able to make any through mutating, just MO and OR, which started already here. Moo and OR. Let's try one more that we can do with a mutation that will be successful. Let's try MO, MMO. RR. All right, last one. Looking through, I can see I'm going for 2 hits. I've got an MOO, so that's potential candidate for mutation. OOR is nothing. ORA is nothing. RA, that's a potential candidate mutation. If I could find another RA. AMM, that's a candidate for mutation. A and M, MMO, MO, ORR. ORR is a potential candidate for mutation. OR. So these are all candidates for mutations. They've occurred 1 time, but not twice, which means for each one of them, I'm going to check to see if I can make another through mutating. Let's start with moo, the MO. So no, 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 no. Ooh, this one will. And this MO is the start of an MOR, which is not a moo, which means I can safely mutate that to an O and make a second moo. As soon as I find that, I don't have to keep iterating, by the way. Once you get your 1 mutation, you can break out of your loop and go to the next one. MO is a success. Let's do RA, see if I can make a second RA. No, 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 that's already an RAA. No, 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 no. RA is disqualified. Let's try to make a second AMM. No, 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 no. Ooh, we had this one before though. I can't change the middle letter here because that's already the start of an AMM. And then that's already AMM. No, no, nope. So AM is disqualified. Last one is going to be ORR. Here. Oop, I could mutate that one. The only way that would be a problem is since this is in fact an O, which is the first letter, I got to make sure this isn't already an ORR. But that's not the case, which means I can make that ORR. That gives me my second ORR. Now I can immediately break out and declare this one successful as well. And I don't have to check the rest of the string. So my 2 successes there are MO and OR, and I've got 2 of them. All right, that's it. Let's code it up. First, we're going to include IOStream using namespace standard int main. Return 0, and let's make mooin /mooin. Fabulous. So we're going to start with n and f, int n and f, cn and f. From there, then we have our phrase, string phrase, cn phrase. As far as the phrase goes, those are all going to be lowercase letters A through Z. Just to make them easier to work with, I intend to use them as indexes in an array later. So A would be 0, B would be 1, C would be 2, and so forth. That's going to be easier to facilitate if I just turn all the letters into integers to start with. So even though I've got my phrase as a string, which I can very easily iterate through, I'm going to create an integer array. Letters. Once I do that, I'm going to run through int I equals 0, I less than n, I plus plus, and set letters at I equal to phrase at I minus the letter A. So now all my letters will be in lowercase. And just to test that, we'll do for int I equals 0, I less than n, cout letters I, make mooin /mooin. Let's do 5 letters. The F doesn't matter. A, B, D, Y, Z. So you can see 0 for A, 1 for B, 3 for D, 24 and 25 are Y and Z. What I'm going to do is for any moo, I'm going to use the first letter as the row in a 2D array. And then the next letter, which the next 2 are going to be the same, is going to be the column in that same 2D array. So if I wanted to have like CDD, for example, A, B, C, C is index 2. So I'll go to row 2 and then column 3 for D. And whatever number is there, that's going to be how many occurrences of CDD there are in the phrase. In order for that to work, we're going to create a alphabet of count, int count 26 by 26 for each of the letters of the alphabet. I'm going to have to initialize that all to zeros. For int j equals 0, j less than 26, j plus plus, count at I, j is going to be set equal to 0. So now what I'll do is I'll initially run through and see for each of the possible combinations how many times it occurs naturally already in the existing phrase. But I don't need to look at every one of the 26 letter combinations. I can do that just by running through the phrase. So for int I equals 0, I is less than n minus 2, because I want to stop 2 from the end so that I have the 2 letters after. For each of those, if my letters at I is different from my letters at I plus 1, and my letters at I plus 1 is equal to my letters at I plus 2, that's a naturally occurring moo of some structure. And the first letter is letters I, which is a number now from 0 to 25. And my next one is letters I plus 1. And I can use these as indexes in my count. So my count at letters I plus 1 goes up by 1, plus plus. And just for a sanity check, I'm going to run through at the end. I equals 0, I less than 26, I plus plus, for int j equals 0, j less than 26, j plus plus. This is going to be at the very end how I report the solution. Anything that has a count above or equal to f, if my count at ij is greater than or equal to my target f, then I want to see out the value at I and then twice the value at j. To make that easy, I'm just going to go ahead and make a string of the alphabet, A, B, C, D, E, F, G, H, W, X, Y, Z. And then I can just index it. That'll be easier than casting. That'll be a little bit easier, and I think that probably is honestly a little bit quicker because it's an index lookup rather than adding 2 values and then casting. Alpha I, alpha J, alpha J. This will naturally be alphabetized because I'm going to go through my row first, which will start at A, and then go A through Z, and then B, A through Z, C, A through Z, and so forth. Let's go ahead and test that real quick. That should be enough to, not dealing with the mutations yet, but just to count how many times moos are naturally occurring. Make Mooin /Mooin. We're going to do, let's do 9 letters, 1 occurrence, BAA, MOO, CQQ. Yep, okay, and then we have BAA, CQQ, MO. It alphabetized them. If I have to do 2 occurrences, let's do 9, 2, moo, ba, moo, and I should only have moo. We also should have the count. I'm going to do that at the same time I mutate. We're going to call that hits because I'm already using count. Hits equals 0. It's a hit if it figures out a way to make the required F number of them. So now what I want to do is I want to go through all of the pairs of letters. I want to go through all 650 of these and see how many of them are already at F, how many of them are at F minus 1, and how many of them are less than F minus 1. We're only allowed 1 mutation. Rather than trying every possible mutation of every possible letter, what I'm going to do is I'm going to select only potential candidates for a mutation, which are the ones that are already at exactly F minus 1. If they already have F matches or more, I don't need to mutate. And if it's F minus 2 matches, I can't create 2 more with a single mutation. So we're going to run through for int I equals 0, I less than 26, I plus plus, for int j equals 0, j less than 26, j plus plus. We'll go ahead and check if I is not equal to j. I guess I could do if I equals j, continue. That's a little cleaner. Continue. Basically, if I is equal to j, I don't want to consider it because they have to be different letters. So if I is equal to j, then we're going to continue, which means we're going to go to the next letter. If the count of ij is less than f minus 1, also we continue. Because if I'm short 2 or more matches, there's no possible way to make a mutation fix that problem. So if I'm less than f minus 1, then it's a failure. If the count at ij is greater than or equal to f, then I don't need to do any mutation. I can just do hits plus plus and continue again. Continue. All of these are situations where there's no need to do a mutation. Now, only when we get down here are we in a situation where our count is exactly f minus 1. We need to try to create a new moo with a mutation. But we need to remember that that mutation can't destroy an existing moo. Let's get prepared to iterate for all our letters. For int k equals 0, while k is less than n minus 2, k plus plus. Starting from the beginning and going 2 letters out, for every single set of 3 letters, could I turn that into a moo with a single mutation without disrupting an existing moo? Let's say like I have MO, MOO. If I'm looking for moos, I've got one naturally occurring moo here. If I look here, I could mutate that into a moo by changing that M, but I would gain one and lose one, which doesn't do me any good. So what if it was something like this, MMOOO? I've already got a naturally occurring moo here. I could mutate the middle letter of this and create a moo, but it's the same problem. I would end up losing a moo in the process. Finally, I could turn this letter here into if this was an O, I could turn this into an M to make MOO, but that would disrupt a moo here as well. When we are considering the different situations, I have MO and I'll use X for something else. So I have MO with something else. I have MX and then O, and then I have XOO. Now in the case of MOX, I can't use this, can't use if X is M and followed by OO. For this one, can't use if X is M and followed by OO. Finally with this one's a little trickier, but this one can't use if X is O and preceded by MO. If this was an O, then I can't use that if there was a MO right before it. So those are the cases we have to check for. Let's check for each of them one by one. If letters K is equal to I, which is the M, and letters K plus 1 is equal to J, and letters K plus 2 is not equal to J, then I've got MOX structure. The only time I can't use this is, if this was MOMOO, this is the only time I'm not allowed to mutate this letter. I can't mutate this letter if it's starting a moo. If K plus 4 is less than N, which means if I were to say, for example, K is here, then this is plus 1, 2, 3, and 4. And letters at K plus 2 is I, and letters at K plus 3 is J, and letters at K plus 4 is also J, then I can't use this. It breaks a moo. Otherwise, we'll do hits plus plus and count at I, J, plus plus, and then we don't have any further mutation, so we'll break out. So I'm gonna test that. I'm gonna do make Mooin ./Mooin. We're gonna go 62 MOO, MOX, and that should work. And that sees that I found 2 moos, that's perfect. But if I were to run it with 5-2 and have MO, this one will count as 1, but when it looks for the mutation, it should disregard this MOM, and it did. Okay, so that looks like that's working correctly. Next form, if letters at K is I, and letters at K plus 1 is not J, and letters at K plus 2 is J. This is my MXO situation. If this is already an M followed by 2 O's, then this is not safe to mutate. If K plus 3 is less than N, and letters at K plus 1 is I, which is the M, and we already know letters K plus 2 is J, so I don't need to check for that again, actually. And letters at K plus 3 is J, which is the O, then I can't use. Can't use, breaks a moo. Else, hits plus plus, count I, J, plus plus, and break. Let's test this with this MXO. So we're gonna do make Mooin, let's do 5-2, and then MMOOO. Should not succeed, but if I do it again, 6-2, MXO, MOO, that should work. And then I got 2 that time, so that looks like that worked. Last case, if letters at K is not equal to I, and letters at K plus 1 is equal to J, and letters at K plus 2 is equal to J, then I've got the form XOO. The only time I can't use that now, if this is K, is if K is at least K minus 1 minus 2. If K minus 2 is greater than or equal to 0, which means that I have 2 letters before, and letters at K minus 2 is I, and letters at K minus 1 is J, and letters at K is a J, then I can't mutate this to an M because that actually is an MOO already. And then mutating this to an M would break a preceding moo. Can't use, breaks a moo, else hits plus plus, count I, J, plus plus. Finally, reporting our hits, see out hits, and I think this is now done. Make Mooin, this should be 1 moo. Oh, we gotta fix that output. I just wanna output what it was. Second sample case, the 17-2. Ooh. Came up with 6. Is it just doubling them? Oh, because I didn't break here. Break. Let's try that again. Yep, there we go. 3 AQQ. Last one. Mooin 31000. And I got my 25. All right, let's submit it. Okay, C++. Mooin time. Here we go. All right, Mooin time. It's Mooin time. Submit solution. Ooh, got a couple of those wrong. All right, let's see. What did we do wrong? Actually, there are 2 cases for this one, for XOO, that we can't use. One is if K is here and it's preceded by MOO, but the other one is actually if K is here and it's preceded by M and then followed by O. We need to make sure that we're not preceded by either an MOO or simply an MO. Else, if K minus 1 is greater than or equal to 0, and letters at k minus 1 is I, and letters at k is j. And then we've already verified that letters at k plus 1 is already j. I don't have to check for the next O. Then also can't use breaks a moo. Let's try resubmitting that. Choose file, Mooin, submit. All right, let's move on to Java. We're going to import Java util scanner, class Mooin, public, void main, string args, scanner, sc equals new scanner, system in, int n, sc next int f, sc next int, sc next line, take it to the next line, and then string phrase equals sc next line. Just a real quick note, if you use next int and then you're going to get a string data on a following line, you have to do sc next line to get down to the next line. Otherwise, this just ends up empty. That's really easy to demonstrate. A lot of people have issues with this. Real quick, I'll show you how that works. If I do this and then system out print line n, good a time as any, do a sanity check, f, phrase, java c, mooin.java, java, mooin. So if I have this to start with and I paste in my input here, you'll notice the phrase is going to be blank. So I got 10.2, but then no phrase. And the reason why is because this next line grabbed the next line after the 10.2 of input. If I put in this sc next line, do the same thing, java mooin and paste. Now you can see I got 10.2 in the phrase. Let's take this out. So first thing I want to do, I would really rather work with these as integers rather than characters. Lowercase a is like 97. It's just going to be easier to set up an array. So I'm going to do int letters equals new int size n. For int I equals 0, while I is less than n, I plus plus. Letters at I is going to be equal to phrase char at I minus a. And that's just going to shift everything down to 0. So now a is 0, b is 1, c is 2, and so forth. The m is going to be the row in a 2D grid that's 26 by 26. So if I want to know how many times I have BAA, I'll go down to B, which would be index 1. Go to A, which is index 0, and whatever that number is, that's how many times I have ba. If I want to know how many times I have MOO, I go down to the M, over to the O, and whatever that number is, that's how many times I have moo. Int count equals new int 26 by 26. I don't need to initialize that. Java always initializes arrays to zeros, so we don't have to worry about that. We're going to go through and count how many naturally occurring moos we have without any mutations. For int I equals 0, while I is less than n minus 2, I plus plus, whoops. If letters at I is not equal to letters at I plus 1, and letters at I plus 1 is equal to letters at I plus 2, then that means that the first letter is different from the second letter, and the second letter is equal to the third letter. That means it's some sort of a moo, where my first letter is letters I, and my next letter is letters at I plus 1. And if it's BAA, then that means that B is not equal to the first A, and then the first A is equal to the second A. If that's the case, then I'm going to use my count structure at that row and column. I'm going to add 1 to that. That's one more occurrence of that particular pattern. And just to go through and sort of sanity check this as well at the end, in the end when I'm reporting my results, I'm going to have for int I equals 0, I less than 26, I plus plus. For int j equals 0, j less than 26, j plus plus. If count at ij is greater than or equal to my f score, I'm just going to do string alpha equals abcd. So I'm going to do alpha char at, this is probably the easiest way to do, I'm doing C out. I just finished doing C plus. System out print line alpha char at I. This is going to be tricky too, because if I add characters, it's going to try and do math with them. Plus alpha char at j, plus alpha char at j. Let's just real quick see if that works. We're going to do java c mooin.java, java mooin. We're going to do just like 6.2 moo. Okay, and we caught moo. That was the moo coming back as output because the count was equal to 2. Just to demonstrate that, I'll go ahead and put the count in here as well. Count I, j, plus space, java c, java mooin, 9, 2, and then moo. You can see I got 3 moos. If I do java mooin, 9, 2, moo, ba, moo, that still works. Now I've got 2 moos. Okay, looks like we're in good shape on reporting the answer. The last thing we have to do is we have to deal with the mutation. So I want to look through all of my counts and figure out, what do I already have enough of? What is it that can't possibly qualify because it would take more than one mutation? And what is it that could potentially qualify with one mutation provided it's available in the string and provided it doesn't break something we already have? We're going to do a for loop for int I equals 0 while I is less than 26 I plus plus, for int j equals 0, j less than 26 j plus plus, if the count, I actually have hits, int hits is 0, if I is equal to j, it can't be a moo. We're going to remove things that are impossible. If the letters are the same, can't be a moo. If the count at ij is less than f minus 1, that means we would need more than one mutation, which means this can't possibly work. We'll do continue. If the count at ij is already greater than or equal to f, we don't need to do a mutation because we already have enough successes, so why bother? We'll count that as a hit, and then we'll continue. Finally, if we get down here, we have a potential to create one with a mutation. In order to do that, I'm going to make a for loop for k equals 0 while k is less than n minus 2, k plus plus, and we're going to check to see, do we have a pattern where the letter k is at the start of something that could mutate into a moo, but whatever letter needs to mutate doesn't break an existing moo. So I'm going to write out the three cases for that and where that's going to be a problem. So we have MOX, where the last letter change could make a moo. MXO, where the middle letter change could make a moo. And we have XOO, where the first letter change could make a moo. Each of these potentially has a problem. First, we'll start by identifying these cases. If letters at k is equal to I, which is my M, and letters at k plus 1 is equal to j, which is my first O, and letters at k plus 2 is not equal to j, then that means I've got an MO and then something that isn't an O. If that's the case, I need to make sure that what I don't have is MO, MOO. Because if this X character, if k is here, and then this is k plus 1, 2, 3, 4. If the item at k plus 2 is not an O, but is in fact an M followed by two O's, then I'm not allowed to mutate. If k plus 4 is less than n, and letters at k plus 2 is an M, letters at k plus 3 is an O, and letters at k plus 4 is an O, then I can't use it. Otherwise, hits plus plus, count at ij plus plus, and we'll break because we don't need to look for any more mutations. We're done. For MXO, we have a similar situation. If letters at k equals I, and letters at k plus 1 is not equal to j, and letters at k plus 2 is equal to j, then I've got the MXO situation. The only time I can't do this, if this is where k is, then I have k plus 1, 2, 3. If I have an extra O here, and the one at index 1 is an M, I can't mutate this M to an O because I would gain a moo and lose a moo. If k plus 3 is less than n, and letters at k plus 1 is in fact M, we already know that letters k plus 2 is an O, but letters at k plus 3 is a J. If that's the case, then I've got MMOO, and I can't use that. Else, hits plus plus, count at ij, j plus plus, and finally break. This last one's a little tricky because there's two different situations that mean I can't use this one. If this is an O and it's preceded by an M, or if this is an O preceded by an O, which is preceded by an M. As in either of those situations, if I change this to an M to make that moo, I lose a moo. Or in this situation, if I change that to an M to gain a moo, I lose the moo that was before it. So I have to check for both of those. To identify the XOO, if letters at K is not equal to I, and letters at k plus 1 is equal to j, and letters k plus 2 is equal to j, then we have the XOO situation. If k minus 1 is greater or equal to 0, and letters at k minus 1 is equal to I, and letters at k is equal to j, and we already know that letters k plus 1 is equal to j. If all that's the case, breaks a moo. Else, if k minus 2 is greater than or equal to 0, and letters at k minus 2 is I, and letters at k minus 1 is j, and letters at k is j. This is k minus 2 minus 1. Here's k, and then here's plus 1 plus 2. If minus 1 is an M, k is an O, and k plus 1 is an O, then I can't mutate the character at k. And if minus 2 is an M followed by two O's, then I can't mutate the character at k to make the O either. Also can't use. Finally, we'll do the same thing we did before. Hits plus plus, count at ij, plus plus, break. Finally, we got to print out our hits. So then that looks like that should be good. I'm just going to go ahead and go straight to submit it. I'm going to go Java, mooin.java, submit. Let's see how we did. Oh, that should be equal to j. Where did I do that? Line 99. Equal to j. Mooin Java. Oh, I have extra output. It's past my bedtime. Oh, we're doing math. That was working before. Plus. It did 331 because it did the ASCII values added all together. One more time. Whoop. My brain is fully shutting down. Let's try this one more time. Okay, submit. Looking good. All right, we're through it. On to Python. Okay. We'll start by getting n and f. Map int onto input.strip.split. Print and f. Let me just make sure that's going to work. Clear Python 3, mooin.py, 3.4. Yep, okay, we look good. Then we're going to read the phrase. Phrase equals input. Might as well strip it just in case. Much like with the C++ and Java, I want to turn this phrase into a list of integers. Integers are just going to be easier to work with. I'm going to have to use ORD. I'm just going to use ORD. So just real quick, if you're not familiar with ORD, if I do ORD of A, it'll give me the ASCII value of it. So then I could do ORD of, like, for example, C minus the ORD of A, and I can figure out that the C is going to be index 2. ORD of B minus A would be 1. ORD of A minus A is going to be 0. And I'm going to use that in a 2D array where the M of the moo is going to be the row, and then the O of the moo is going to be the column, and I'm going to turn them into ordinal numbers. So M, O, and that'll be how many times that occurs. But I don't want to start at 97 since the ordinality of A is 97. So I'm going to just subtract A from everything. I'm going to have letters. And I could probably do this with a list comprehension, but again, I kind of just want to be lazy. For letter in phrase, letters append ORD of that letter minus the ORD of A. Once I'm done, I'm going to print out the letters. We'll just try this out real quick. Python 3, mooin.py, 5.2, AB, M, Y, Z. So A should be 0, B should be 1, M is like 14 or something, and then Y and Z should be 24 and 25. So now I have my list of integers. And these represent what letter of the alphabet they are, which is great because then I can use that as an index. So what I'm going to do for my character arrays is I'm going to have count be a list of lists. And then we'll do for I in range 26, because I have 26 rows. For each row, I'm going to do count append a 0 times 26. This 0 times 26, 0 times 26 will just give me a list of 26 zeros, which I'm going to append to my count. I'll just go ahead and print count to show what that looks like. Whoops. 5, 3, A, B, C, D, I guess it doesn't matter. Here's a list of 26. So now what I'm going to do is for every potential starting index for a 3-letter sequence, I'm going to check to see if the first letter is different from the second letter, and the second letter is the same as the third letter, then that's got the form of a moo, and I want to count that in my counts. So for I in range n minus 2. If letters at I is not equal to letters I plus 1, and letters at I plus 1 is equal to letters at I plus 2, then I've got something in the form of a moo. Letters I would be the first letter of the moo, and letters I plus 1 is the second letter of the moo. And then the third letter is going to be the same. What I can do then is count at that index plus 1. And so just to test that out, I in range 26, or J in range 26. We'll do alpha. We're going to print alpha I plus alpha J plus alpha J. We'll go ahead and test that out real quick. Oh, I'm still doing C++ and Java syntax. And we're going to do 6.2 moo moo. Ooh, we got too many. Oh, because I'm printing everything. Also, it's actually a good time to point this out. It alphabetizes because I is going from 0 to 26, which starts at A, so it's going to start with the first character at A. And then J, which is inside, is going to go from 0 to 26. I don't want to print all of them, though. I only want to print if the count at IJ is greater than or equal to my F minimum. Then I can print it. 6.2 moo moo, and there's moo. If I do 12.2 moo ba, then I got ba and moo. And ba came first. We look like we're off to a good start. What we need to do now is we need to count how many total matches we have, as well as figuring out what already has enough of a count versus what can we potentially do through mutation. So for I in range 26, for J in range 26. And in this case, I represents the M and J represents the O. If I is equal to J, it can't be a moo. Continue. Hits equals 0. Okay, if my count at IJ is less than F minus 1. If it's less than F minus 1, then I would need at least 2 mutations, and I'm not allowed to have 2 mutations, which means this can't possibly work either. If count at IJ is already greater than or equal to F, I don't need to use a mutation because I've already got a success. Hits plus 1, continue. Finally, if we get down here, then the implication is that I is different than J, and we have exactly f minus 1 in the count. Now what we're going to do is we're going to look through the string and see if we can find at least one site where we can mutate. In order to mutate, the site that we find to mutate has to follow either the pattern MOX, MXO, or XOO. And each of these is going to have their own restrictions and issues. For MOX, for example, if I have a MOX where I've got an M, if this is index K, and then K plus 1, K plus 2, and then K plus 3, K plus 4. We'll need that in a minute. If I have K and K plus 1 are M and O, but K plus 2 is not an O, but K plus 2 is an M, and then K plus 3 and K plus 4 are both O's, then I already have a mu here. And if I mutate this M to an O, I gain a mu and lose a mu, which means it's not a useful mutation. If letters at K, oops, I gotta start my loop first, for K in range n minus 2. If letters at K is equal to I, and letters at K plus 1 is equal to J, and letters at K plus 2 is not equal to J, then I've got the MOX pattern. But if letters at K plus 2 is equal to I, which is my M, and letters at K plus 3 is equal to J, and letters at K plus 4 is equal to J, and if K plus 4 is less than N. Because if K plus 4 is not less than N, then I don't have letters there. If this is shorter than that, then this can't possibly be, even if this is an MO. I'm clear. Only if there are 4 letters after the K and 2, 3, and 4 letters after the K form a mu am I unallowed to mutate this character right here. So if that's the case, then we'll just say pass, because we can't use that one. Else, hits plus 1, count at IJ plus 1, and we'll break out of this loop because this is my mutation search, and then there's no reason to search for additional mutations because I've already used the one mutation that I'm allowed. For MXO, this is allowed provided that the X is not an M, and then there's not an extra O at the end. If K is here, and then 1, 2, 3. If I have M at K and O at 2 past K, but 1 past K is an M and 3 past K is an O, then I've got a mu here, and mutating this M to an O is just gonna break a mu in order to gain a mu. So it's the same thing. If letters at K equals I, and letters at K plus 1 is not equal to J, and letters at K plus 2 is equal to J, then if K plus 3 is less than N, and letters at K plus 1 is equal to my M, we already know that K plus 2 is equal to J, and letters at K plus 3 is equal to J, then I have to skip that. Else, same story, hits plus 1, count IJ plus 1, and then break. And then our final mutation situation is the XOO. Now this is a little tricky because there's 2 situations that'll mess us up here. One is if this is K, and then in the K minus 1 position we have an M, and the X site is an O. If I have OOO, but it's preceded by an M, then I can't use that one. And then the same if it's MOOOO. Then likewise, I can't mutate this to make an MOO because I already have a mu before it. So that's going to require an extra check. If letters at K is not equal to I, and letters at K plus 1 is equal to J, and letters at K plus 2 is equal to J, then if K minus 1 is greater or equal to 0, and letters at K minus 1 is equal to I, and letters at K is equal to J, and we already know K plus 1 is equal to J. If K is equal to J, then we have to pass. If K minus 2 is greater than or equal to 0, and letters at K minus 2 is equal to I, and letters at K minus 1 is equal to J, and letters at K is equal to J, then we have to pass that as well. Because that's the situation where 2 letters before K is an M, and then 1 letter before K is an O, and then the letter at K is an O. Then if that's the case, I can't mutate this one and make a mu. Finally, else hits plus 1, count at IJ plus 1, and we have to print our hits. I'm gonna go ahead and test that. Python 3, we'll just grab this one right here. Paste, ooh, I got 4 hits. Oh, I missed a break here. Break, okay, let's try that again. Paste, yep, 3, there we go. All right, we'll fire up the website. I'm gonna switch to Python 3, choose file, Mooin py, open, submit. Fabulous. That one was kind of tricky. Had me feeling a little bit more boast there for a second. Did anyone actually watch this movie? Let me know in the comments. Hopefully that was helpful, and I'll talk to you on the next problem. Oh, I'm about to farm out. It's farming time.